Okay, this is a really nice question about energy density, really equation heavy, this one. So if you've got a taste for equations, this is one for you. As ever, press pause, try the question, and then we'll see how we get on with the answer. Okay, so I think it's really key to just have a look at some of our quantities here. We've got an engine providing a thrust force F, and it's moving at constant velocity V. And we've got the efficiency E and energy density. Ooh, what's that letter? Eta? I can't remember. I never remember. I'm just going to call it N for now. My apologies. My Greek is not with me today. Now, the tricky bit here is we want to know the rate at which the volume of fuel is being consumed by the engine. Now, that's the tricky bit here. Okay, what are we actually trying to find out? Sorry about the background noise here. I'm competing with Year 7, so I'll move away from them. Let's have a look here. The thing to do in a situation like this is always to have a little think about the equations you know. And this is a question about forces and velocities, densities and efficiency. So let's just set some of those things out. First thing I did was I thought about the output energy in this system. Firstly, we know that we're traveling at constant velocity. We can use our P equal to FV, and I've used power out here. Now the energy out is just going to be the power out times some delta t, some time frame. Okay, so we've got F times V times delta t. The reason I've done that delta t is because I want to know the rate of volume consumption. That's going to involve time, so I've kept a delta t in there, and that's going to eventually give me my answer. I then thought about this input energy. Well, the input energy comes from the fuel, and as I burn the fuel, we're going to take that energy density, we're going to multiply it by the change in the volume of the fuel that we're using. Notice again here, I've got delta V and delta T. That's going to allow me to answer the question. Now the link between these two equations, I appreciate it's a tricky one. Okay, we're going to use efficiency. Is energy out over energy in. In this case, energy out is FV delta T, and then we've got on the bottom our N delta V. Why is that relevant? Well, hopefully you can see now we can rearrange this for delta V over delta T, which is equal to FV over NE or EN, which is the answer which is given in A. Now, I appreciate this is quite a tricky one because you use lots of equations joined together, equipped with, on top of the fact that we want to do this delta V over delta T. However, it's a really nice, good understanding of just your recall of those equations and where we should apply them.